So now that we have a way to describe the central tendency, or we have some different measures of center, the mean, the median, and the mode, and we've discussed which one we should use, why we should use it then, you know, now's the time to take another step further into describing some sort of numerical data set that we might have, right? Now, understanding where a data set is centered is really valuable information. I think we all have probably used averages throughout our life for one reason or another. Grade averages, if you're in sports, maybe like a batting percentage as an average, things of that nature. Um, but it's also helpful to understand not only where the center of a distribution or a data set is, but also how spread out that data set is, right? And what we can do to help us figure that out is we can use the 5-number summary. Now, as you could imagine, the 5-number summary, it consists of 5 numbers, right? And what it tells us is it tells us the minimum, the lower or the first quartile, Q1, the median, right? This is one that we already know. This is one of our measures of center. And the upper or the third quartile, this is missing the notation here, often notated as Q3, and the maximum, right? And more often than not, you're going to see them expressed as a tuple, right? These sort of ordered pairs or ordered tuples are something really common both in mathematics and in programming, right? There's an inherent order to these 5 items, right? It goes from smallest to largest, right? This tells us the smallest value in our data set, the largest value in our data set, the center value in our data set, and then this Q1 and this Q3. So if you can actually imagine it, and in the next video, when we talk about actually calculating the 5-number summary, we do an example. We'll maybe look at a little diagram, right? What this does is it actually breaks up the distribution into 4 little sections, right? You have the section from the minimum to Q1, from Q1 to the median, from the median to Q3, and then the section from Q3 to the max, right? These are typically referred to as the 4 quartiles, right? We have the lower quartile, everything below Q1, the second quartile between Q1 and the median, and then the third quartile between Q2 and Q3, and the fourth quartile between Q3 and Q4, right? So this 5-number summary gives us an idea of the overall distribution beyond just some measure of center, right? It might say, hey, the minimum is 27. Let's say we're talking about let's actually talk about horsepower for vehicles on the road, right? We might see that the minimum is 27 horsepower. That's very little power. And the maximum is 450 horsepower. And our median is actually like 180. But even though the minimum is 27, Q1 is likely going to be around maybe 100 or 110, right? And that's indicative to us that there is some sort of outlier, right? And when I thought about that data set, I said, oh, that's probably someone on a scooter compared to everyone else who's in a car, right? So I do have an idea of the overall spread of my data, right? But I also have an idea that, like really most of the data is above 100, right? If Q1 was 100, even if the minimum was 27, right? That's saying 75% of my data is greater than 100, right? So it breaks it down into these 4 quartiles where 25% of the data is in the min, 25% of the data, or excuse me, in the first quartile, 25 in the second, 25 in the third, 25 in the fourth, right? And if we actually go over to our data visualizations or common plots, there's a box plots really visualize the 5-number summary, and these two things really go in hand in hand, right? We can see, how a data set is distributed, right? Because each one of these distances contains 25% of the data, right? So I can see that this is actually pretty sparse, right? There's a lot of space in between Q1 and the median, right? It's a little bit sparse. And we can see further, this shows some outliers instead of, the max being all the way up here at 20. But again, I can really see the distribution of this data. Like, yes, my max is 20, but almost all of my data is centered, at less than 10 or less than 12, right? So, these 5-number summaries that we use can be really valuable to us to describe how a data set is distributed, right? And you're going to hear me say the word distribution about 1,000,000 times throughout this course, and that's what we're talking about, right? We're talking about the way the data, whether it's actual data or theoretical data, is distributed along some number line, right? So that's the breakdown of the 5-number summary. How we actually calculate it and breaking that down in Python is something that we're going to do in the next video. We'll see you over there, and make sure to like and subscribe, and we'll catch you soon.